Problem number 6?
Yes.
All right. So problem number Zalachi. Yeah?
Your pen is dying.
Okay. Hui? Hui would be no. So what's yes?
C.
No, it's not.
Oh, goodness.
All right. So did I.
Maybe we should put those on the wall too.
Yeah, we need to. All right, so what this thing says is it has bisectors. This is a bisector. This is bisecting this angle. They're angle bisectors. All right, before it was perpendicular bisectors. Nope, these are angle bisectors. Now, angle bisectors meet at a very special point, right? And that special point is called a incenter.
Do those only occur in angle bisectors?
Yes. Incenters are created from angle bisectors. Right? Perpendicular bisectors, they cause what we call circumcenters. Right? Incenters are what we call angle bisectors. Right? And there's something very special with those. It creates these perpendiculars, right? These special perpendiculars. This is a little off. Let me see here. See if I can make this a little better. About there, right? So about there. There. That would be K. And then this perpendicular, that would be perpendicular. Okay. All right, that perpendicular, what happens is it creates these perpendiculars, this special perpendicular, right? That each of these perpendiculars are the same. In fact, they don't have them in this one, but they make this incenter, this circle that goes on the inside. Okay? Now this problem doesn't have this one. It does have this, right? But it doesn't have these two. So I don't think it'll be asking me those things. But what it may ask me is, well, what's the other side to this, right? Also, it gave me 50 and it gave me 21. Right, so 21. Okay. And it asks me for the angle GJH. Okay. Well, one thing I know is if this is 16, what's this? 16. Okay. So, what's the whole?
32.
Yeah, 32. And so if this is 32 and this is 50, then this whole one, right, this big one right here, would be 180 minus the addition of 50 plus 32. Does that make sense?
Hold on, where'd you get the 180 from?
Just all three angles in the triangle add up to be 180,
Oh, okay.
right?
Yeah.
And then we subtract 50 plus 32, or in this case, 82, right? And when we subtract 82 from 180, how much do we get? 98. Okay? And so that means this big one is 98. Now if we cut that in half, how much are these two pieces? If we cut that in half, how much would this angle be and how much would this angle be? The whole angle is 98. How much would each angle be?
34.
Good. Close. 49?
Mm-hmm.
So 98 divided by 2. 2 goes into 9 4 times, 1 left over. 2 goes into 18 9 times. Okay? That's that short division. Usually it's upside down division. I call it short division. I usually don't even draw the upside down division. I used to just do it in my head. But I found that by drawing the upside down division, people are like, oh, it's just upside down division. Like when I was showing my daughter, she was a lot more susceptible to listening if she's learned it before. Okay. So they're 49. So now I know these two, I know these two. Great. Let's see what they want. They want GJK. So angle GJK. So they want from here to here to here. Alright. Well, that's this guy. Bing, bop, boop. 49. Okay? And I didn't know we were finding that one. I was just finding all the angles. I had an idea, since they're asking an angle, they gave me these two angles. I could find these two pretty easy. Might as well just find them. Right? And then they're asking me the distance from K to HJ. So they're like, hey, they're trying to trick you. HJ is here, right? They're saying, we want this distance. And you're like, I know. Right? If you don't know that this is creating this circle, right? And that this is the radius, you have no clue that it's as easy as that. Now you might be another, YouTube sensation if you just come up with 21, right? We got this 21, right? And you're right, so it's okay. So the height of K, the distance from K to JH is equal to 21. So, but you have to know that from the fact that this is an incenter. And it's an incenter because it's cutting these bisectors in half. Okay? Questions?
So wait, K to HJ was the distance from K to HJ. What does it mean by that?
The distance from K to JH. So it's just saying, hey, the shortest distance is a straight line, right? And the shortest distance, in this case, will be perpendicular, right? Because any other distance is going to be a little longer. Does that make sense? If I'm going from this spot to this line, right? The easiest, I could go way over here, right? But if all I want to do is hit the line, the shortest distance is a perpendicular distance.
What in the K in the middle of 21?
No, K is this point right here. That's what we're getting confused.
Oh yeah.
Okay? Okay. Not okay. It's JK.